Good evening, Dr. Mingo. This is Patrick Cook once again, providing the 12-12 update. And before I get started with the demo, because that's primarily what I want to do here, I'd like to kind of go back and do a recap of the project and provide uh, some next steps. So, again, this is SHAMROQ. The primary objective is really to use this methodology called SHAMROQ to programmatically extract software requirements from the GPO data sets that I downloaded from the well in XML format. Uh, the GPO data sets that I'm looking into is the Children Online Privacy Protection Act, which is COPPA. Also, the Graham Leach Bliley Act, GOBA, and one portion of the HIPAA, Health Insurance Portability and Accountability Act of 1996. Uh, uh, just so that I'm clear, I'm not looking at extracting the entire regulation. I'm only looking at sections of it so that I can provide a prototype of the SHAMROQ methodology that is used to extract programmatically software requirements from these regulations. Why? Just to kind of recap on the problem statement here. Uh, Invariably, at least more recently, researchers and practitioners are using regulations in every aspect of our society, and when we're doing that, we're incorporating that into our software. And so we must make sure that software and system engineers observe the right requirements from those regulations, given that there's a lot of ambiguity, there's a lot of cross references. It could conflict between local, state, or perhaps federal law. For example, marijuana is illegal federally, but in some states they've chose to legalize it. So when you're talking about the conflicts there across local, state, and federal, you can see that's just one example. We also recognize that when we're building these solutions, and if they violate the law, it could result in costly penalties. And there are many examples of that. But it could also damage the company's reputation, and in some instances, result in prison time. And so there's a few use cases that I'm looking into. One is extracting the requirements, taking and giving an ontology, which is a kind of description of the terms and their relationships, and also the GPO XML data set that I talked about. I'm looking just to read the XML file, analyze the structure, and put it into an XML format so it can be used. In that particular use case is was a pretty towering task in itself, dealing with the structure of the XML, and even in across regulations, they have some kind of different formats. The second one is to classify. So now that I have this XML tree, there are certain things that I can do with that. I like to kind of read each provision and classify the grounding elements in that, which is primarily the Hofeldian incident, whether it's a right, an obligation, or permission, or things of that nature. Also, I'd like to get the meta model out of it, and that meta model is basically the subject, modality, action, an object, and in some cases, an indirect object from that particular the document, so that I can begin to put into an XML legal rule in XML. And then finally, take the ancillary elements of the sentence that are not subject, modality, action, and object, and look at those other things, those thematic roles, or what they call semantic roles. And these take the form, in most cases, as prepositional phrases. And so we'll get the theme, the instrument, goal, the location, but primarily, not only are we looking at extracting the SVO, subject, verb, object, out of that, and the modality, which is the Hofeldian element of it, or at least the key indicator, we also need to take a look at the other elements of the natural language that's provided part of that provision, and that's a part of this work as well. And then we model their requirements, and we're using legal rule ML, the legal rule modeling language, which is a derivative of the rule modeling language, which was codified or solidified in August of 2021. So a little bit over a year ago, the legal rule specification as an OASIS standard is now available to be used, and I'm using that in this particular solution. So I'll use the defeasible logic representation, and I'll use the deontic operators and temporal management that's laid out in the legal rule specification as a way to model these requirements in XML. And then finally, the last part here is to be able to query it. So given this knowledge base, these software requirements, this ontology, this legal rule representation, and all the things that are associated with pulling that information out and modeling it, now I need to be able to provide a query language so that I can ask questions of this model to make sure it properly represents the particular provision. And after the demo, there's a few next steps that I have. I have not completed the work entirely. I still need to incorporate the ontology using this OWL-Ready2 Python library. It's up to version 0.39 right now. And this package is really for creating the ontology along with allowing to modify, save, and perform reasoning, and it's going to support the query. It also has a swirl libraries as a part of this particular package, and I'll be using that as well, at least using it as an option. And I've already tested the OWL2 Python library, and I'll demo that here pretty shortly, so you'll see what I mean by this OWL2 library. Also, a part of the next steps, what I need to do here is to create this legal rule XML instance programmatically. Uh, I'm able to now validate the schema. There were three kind of layers of the schema. There was the legal rule XML specification, then it included the rule ML specification, and it included these data types. And that caused some problems when in initial validations, but I was now able to validate it. So now what I need to do is to programmatically create a legal rule instance of this particular XML, and then validate that instance to get the specification or the schema for legal rule LML. And I was able to do that as well. And I'll show that, but I need to now do it programmatically. And then finally, once I get these next components in there, I'll do some end-to-end testing and then capture my findings and then write up the report. And so I'm ready to kind of start with the demo, but let me first talk about what I want to show. So the legal rule specifications I talked about, I actually was able to get this software because after having so many different problems with the XML, I went out and bought this Oxygen XML editor to kind of work through the stanzas within the XML to see what was going on, and I was able to use this technology to finally work out the bugs, and I have a programmatic example here using Jupyter Notebook. Also, I'll run the software and we'll see the CVO, the SVO, subject, verb, and object from the copy regulations. You'll see the defeasible logic format with also the deontic operators that I was able to kind of pull. Now I actually formatted so it can be explicit, but what that just says is I have the data and I can use that data in varying degrees of processes. So right now I'm just printing it out, but the goal would be to take the data, the SVO, subject verb object, along with the thematic or the semantic roles, and now put that into the legal rule XML format, which is that instance of legal rule XML that I was talking about earlier. All right, so without further ado, let me just run over here and do this real quick. So we want to first talk about this XML instance here. So here's this tool, Oxygen XML, and it's for a developer. I actually used it for a while, and then I was able to go ahead and buy the license because I found it to be very useful. But the legal rule XML has different types of format. They have a compact format, they have a normal format, And so of these format, I chose to use the compact format because it's less verbose, right? The normal version of legal rule LML, the specification will tell you that it is kind of, it has a lot of more elements inside the schema than, it's not necessarily required, but you can certainly use the compact version to be able to get, to make the best use of it, and it's certainly less verbose. And so we look at the legal rule specification, and you see here that it includes or imports the rule XML, the rule modeling language here as well. And when we go to the rule modeling language, you'll see that it incorporates or it adds this data types, simple with attributes. And when we go this particular data types is simple with attributes XSD. It incorporates this XML schema data types XML. Originally, this was a HTTP address that I had to go out to kind of pull down to validate it. But after doing that for a while, it did not validate because it did not like the way it was structured. In fact, it didn't like this doc type entity as it was pulling down. So what I did was I pulled this down and made a local copy of it. Then I made a local reference to this particular data file, and then it was able to validate the schema without having an impact of this particular entity problem here of the way they're structured. So then once I was able to do that, which took some time to kind of figure that out, I actually created this instance of this schema. And so here's legal rule XML. You see that it has these, components in here that are part of the specification. And so I kind of documented it in such a way that I could, replicate this, multiple times and have a full appreciation for what these pieces mean. But there are three elements. There's the prefix, and there's the metadata. And the metadata has these legal sources in here, which is kind of tells you what the actual original legal source is. And then it has these references here, which is a different connotation than these legal sources, which means that they both represent the same thing here, but it's captured as a non-IRH based source, and this is an IRH based source, which is a URL in essence. And then you have these times in here, as well as these temporal characteristics that talk about, when this was enacted and how long is duration is for. So these temporal characteristics, along with the times, are just the metadata portions of the legal rule XML specification. And then you have the associations. And so this is where the magic happens, right? So you have the some associations here that talks about each individual rule, and these rules are references to the actual key rules that's down here in what they call the context and the actual statements, the rule statements. And so these associations kind of set the stage for, what rule, what's the reference to that rule, what temporal characteristics associated with that rule, who is the authority that made the rule, and this is Congress, the United States Congress, and then what particular modality or what kind of format that I'm using here. I'm using defeasible logic with deontic operators, and so this kind of sets the stage. This association block say, here's how this will be used down here for these statements. And then finally, when you have these statements there, they really talk about two main parts, which is a prescriptive statement, which is the statements that are associated with obligatory or being permission or being a prohibition. And then you have, which I didn't include yet, but what you have is the other statement, which is called constitutive statement, which is really just a fact, right? It is not, it's not obligatory, anything along those lines. And when we look at the specification here, or at least what it explains is here, I'm using this particular reference, the OASIS Legal Rule XML, to kind of explain these in detail. So it talks about the pieces of it, and it provides some examples on how to do that and what the time and events are and what the context association, which I just talked about, the agents and authority, who's the author of the particular regulations, the feasible representation here, and as well as how you model them. And as you can see here, it'll be using the if then type of modeling using diffeasible logic with deontic operators. And so, in a nutshell, here's the constitutive rules and the prescriptive rules I was just referring to, where you had the constant root norms is just define and create so-called facts, right? They're facts. And the prescriptive rules is to dictate the obligations, the prohibitions, or the permissions. So those are the two representations of the provision or the law that is defined by the schema in legal rule XML. And so, in a nutshell, I'll read the information from the regulation, extract the subject, the verb, the object, the actors, and what action will take place, and what is it act upon, subject, verb, and object. Then I also take the other components of the particular regulations, whether it's a prepositional phrase or indirect object, and I'll make that association to some semantic role. And then once I do that, then I'll finally model it using legal rule XML. So that's in a nutshell what the process is like. And so let's take a look at, I'll run the application real quick. Once more, let's go. Here we go. We'll run it real quick. Okay. And so it's going through and reading COPPA, and it's taking, I've included in this particular version kind of an explicit representation of the parts of speech tags as well as the dependency tags associated with that. So I can see, what 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 patterns emerge from these regulations when you're doing this extraction. I can see what the dependencies are for from sentence to sentence, and so the software, SHAMROQ software, takes a look at the provision. In this case, we're looking at CFR 16, section 312.5, and as we can see here, it takes the metadata associated with the record. Then I extract the header from the particular regulations, and then I take a look at the body of that regulation. Let's take a closer look at the raw version of that. And the raw version of that looks like this. This is the GPO data set pulled down from the GPO. And so as you can see here, it has, this is the header information that I'm extracting from here. And I take that and I have this additional component that I add is the metadata from this particular data. This is not a part of the actual CFR. And then this is the body piece here. So anywhere when you start looking at this section and below, these are the actual provisions, statements that are being extracted, and the information is being parsed to extract the subject, verb, object, and these prepositional phrases which map to some semantic role, whether it's location or whether it's some other thematic role. And so from this particular XML document downloaded from the GPO data set, the program, goes through and extracts this information and it looks at the body. So the first statement, general requirements, it is not a constitutive or prescriptive statement. So the software recognized that, but I did went ahead and pull out, the parts of speech and what it looks like. But you can see is it pulls this information out, it looks at the parts of speech, the tags, as well as the dependency parsing information, and then this child and his answers in the subtree of the information. But it recognizes, oh, this is not a provision, so let's move on to the next part. Then it looks at this, it evaluates this statement. Oh, so it looks at this and it puts out the parts of speech tags associated with each token within each word token or each particular token within this particular text, and it extracts that information and then identifies whether or not it is a determiner or it identifies its head, what the dependencies of it, operator, parts of speech is a noun, and it's the subject in this particular instance. And we look at the auxiliary verb here. And when we look at must, this is an auxiliary verb, so this is it. It has this obligatory aspect of it. So this is one of the deontic operators that will be included, and then it actually has the verb, which is the dependency part here is the root part. And so you can see here that the Spacey library that I'm using is able to review each particular sentence after me doing some extraction of the text and kind of getting the text in a format so I can run it through this Spacey library to get these tokens. And then once I do that, then the software that I wrote, it actually pulls out and look at the grounding and says, okay, if X is an operator and Y consent, then X must is obligated, using the keyword must here, to obtain consent because Y is consent. So this right here takes the format of the if then statement that I talked about in the OASIS legal rule XML format. And so now I can take this because I have this operator, I have the subject, I have the modality must, I have the root verb, which is to obtain, and I have the direct object consent. I can take this now and use this in the legal rule XML to create an instance using this information that I extracted from the regulations. Now, quite naturally, this is not the entire sentence. I still have to take, as I talk about next steps, I still have to take the prepositional phrases. I still have to map them to semantic rows, and then being able to add those elements to the actual the if then statement, if you will, or this particular format that's going to be included into XML. So here's another example of the second part of the statement. Operator must give the parent the option to consent to the collection and use of the child's personal information without consenting to the disclosure. And when we look at that, again, it looks at each individual sentence or token. It looks at the part of speech. It looks at the tags. It explains the tags. It looks at the head dependencies as well as the child's and the subtree of that particular using its dependency parser here. And then again, when I go down here and look at how the software takes that and creates the grounding and meta model, if X is an operator and Y is a parent and Z is an option, then the operator is obligated to give the parent an option, which is an option to consent. So as I mentioned, and then it looks at the next part being B, evaluate statement, methods for variable statement. It recognizes, hey, this is not a particular, so it doesn't evaluate the statement. And so that is, the workings of the software. Those are the kind of the improvements I've made since v.1 a few weeks ago. And then again, as I talk about next steps, as we see here, in the next steps, I still need to do incorporate the ontology using already to. I also need to create an instance using legal rule XML. And what I mean by that is I've done it manually, created an instance here, instance 011. This shows you how many times I tried to get it right, but it didn't. But at any rate, I created an instance here. So now I need to go within the software package and actually program a way to do this, right? To create each individual tag as well as the elements that should populate these tags, the section uh, of the legal section, as well as what associations, what time, all of that is captured from the, from the metadata, who actually was the authority. All of this information should be created programmatically from the information that I'm getting from the GPO data set, so it can be used. So this prototype is really getting there, but it's still some work yet to be done. And the last thing I'd like to show is I talked about using Jupyter Notebook as a way to kind of test some of these strategies out, Allru and a couple of others. And let me just show a couple of instances so here's already where I've actually imported the library, created created this ontology that I made up. I appended the ontology to this particular on path, and then I was able to load it in, and I was able to print it out. And so let me just demo that real quick, and then boom. So you can see it's able to, you know, just basic example, but it's able to capture the ontology that I read in. It was able to add the ontology, load it so I can have access to it. So which means that it'll now be able to be used inside the program because I have access to it. The other thing here that I want to talk about is the validation of the XML schema. So the legal rule XML schema, which is consisted of the actual basis file and the legal rule schema here, plus the instance that I was just working with. And the problem I talked about that I was going to use JSON for early on because of this maximum depth here, throwing all kind of errors. In fact, I may even just show it to you real quick. So without this, let's just say being one, you'll see it fail. Uh, Yeah, so you can see the failure here, and I was just running through this, pulling my hair out for a few weeks trying to figure this out, and it just talked about the maximum model recursion depth exceeded. So after doing some research over time, I was able to find, to read through the documentation, was able to decrease the maximum depth to something higher. I think 33 was the lowest, but since I have not created an instance of this XML that's complete, so I just increased it to the maximum depth to 1,000 so I can have enough room and have to keep increasing it. But 33, I think, is enough depth that's required. But at any rate, once I was able to do that, let me go back in. Okay, so I've increased it back to 1,000, and I'm going to run it again. Validated it true, and it print out um, the actual instance of the XML document that I've created, or at least started creating, and it was able to validate that instance against the actual XML schema, which is which was ultimately my goal, to make sure that once I can create the actual instance from the provision, I can go back in and use the software to validate against that schema so that I know that the instance that we created is correct. Okay, and so that concludes the demo for today. And let me just kind of recap about the demo again. So the demo, we actually looked at the specification, and I showed an instance in the Oxygen XML editor. We looked at the legal rule XML example of that instance that I created and validated that instance against the schema. I ran this SHAMROQ software, and we looked at the subject verb object from the copper regulations. We also captured it in the divisible logic format using if-then modeling, as well as deontic operators by identifying the keyword must or may or right that's associated with the deontic operator of obligation, prohibition, or permission, things of that nature. So ultimately, that we can capture that data and to model it using legal rule XML. And by showing an instance of legal rule XML, now the task just become to be able to use Python to create an XML document that follows that structure of legal rule XML. Next steps, again, as a reminder, we're looking at to incorporate the ontology. I showed the Python example of us, me at least looking at already the library. I'm using version 3.9.39. Also, to create an instance programmatically using Python, and I'll be able to use to create the queries, which is I think was the ultimate ask, to make sure that we can do all of these good things, but so some practitioner can actually use it to query it to make sure that it answers the right questions and things of that nature. And then once I conduct the end-to-end testing, I have it all the pieces together. I'll capture my findings and write a report, and then that will be it. So, by all means, I went over the structure. But if there's any element that you'd like to take a deeper dive, you have more questions about it, I'm happy to just go deeper in one area. But there are a lot of different moving parts here, a lot of technologies, a lot of libraries that I'm using within Python to make this happen. But I'm happy to share any of the techniques that I use, the actual versions of the software that I'm using. I've already put the code up out on GitHub, so it's accessible to you or anybody that want to go out there and take a look at it. So, all right, well, that concludes my 12/12 report. Thank you. All right, bye.